Welcome students. Our today's topic is adjacency matrix of a graph. So in this lecture, first we shall discuss adjacency matrix of a graph. Then I will discuss some properties of adjacency matrix of a graph, and finally I will draw adjacency matrix for a complete graph. So watch this video till end. First, what is adjacency matrix? Adjacency is from word adjacent, and we know what is the meaning of adjacent. As graph theory deals with vertices and edges, if we have two vertices v1 and v2, if there is an edge between v1 and v2, then we say that v1 is adjacent to v2, and we write it as v1 is adjacent to v2. If there is no edge between v1 and v2, then v1 and v2 are not adjacent. That is, there is no edge between v1 and v2. Now we move to adjacency matrix. Adjacency matrix is denoted by AG, A for adjacency matrix for graph G. Now adjacency matrix of a graph consists of two values, 0 and 1. If two vertices vi and vj are not adjacent, mean if there is no edge between vi and vj, then we choose 0 value. If there is an edge between two vertices v1 vi and vj, if vi is adjacent to vj, then we choose 1 value. So for an edge between two vertices, we choose 1 value, and if there is no edge between two vertices, then we choose a 0 value. So adjacency matrix of a graph consists of 0 and 1 value. Now I discuss an example. Here an example, I choose a graph with 4 vertices. We have a graph with vertex 1, vertex 2, vertex 3 and vertex 4. Now I draw some edges from v1 to v3, v1 to v4, v1 to v2 and an edge between v3 and v2. Now I try to draw adjacency matrix for this graph. We have vertices v1, v2, v3 and v4. v1, v2, v3 and v4. Now remember, here we discuss adjacency matrix of a simple graph. In simple graph, there is no parallel edge. Also, in a simple graph, there is no loop in the graph. For example, if we have a graph like this v1, v2, v3, if I have a loop at some edge, suppose a loop at vertex v2, and if there is a parallel edge in the graph, then this graph is not simple. So in simple graph, there is no loop and there is no parallel edge. So we are discussing adjacency matrix for a simple graph. So for simple graph, we have no parallel edges and no loop in the graph. Now for V1 and V1, there is no loop between V1 and V1, so we choose 0 value. Now for V1 and V2, there is an edge between V1 and V2, so I choose 1 value. For V1 and V3, as there is no edge between V1 and V3, so I choose 0 value. There is an edge between V1 and V4. For V1 and V4, we have an edge, so I choose 1 value. Similarly, for vertex V2, V2 has an edge with V1, I choose 1 value here. V2 has no edge with V2, or there is no loop at V2, so we choose 0 value here. V2 and V3 has an edge, so I choose 1 value here. For V2 and V4, there is no edge between V2 and V4, I choose 0 value. Now similarly for vertex V3, V3 has no edge with V1, we choose 0 value. V3 and V2 has an edge, 1 value. There is no loop at V3, we choose 0 value. V3 and V4, there is an edge between V3 and V4, so we choose 1 value here. Similarly for last vertex V4, V4 and V1 have an edge, I choose 1 value here. V4 and V2 have no edge, we choose 0 value. V4 and V3, there is an edge between V4 and V3, so I choose 1 value here. And for V4 and V4, there is no loop at V4, so we choose 0 value. This is our adjacency matrix for this graph. Now adjacency matrix AG for the graph consists of the values 0, 1, 0, 1, 1, 0, 1, 0. This is our second row. 0, 1, 0, 1, and last row is 1, 0, 1, 0. This is our adjacency matrix for this graph. Now student, adjacency matrix gives useful information about a graph. So there are some properties of adjacency matrix. Now I discuss these properties one by one. First property, if we see this adjacency matrix, this is a square matrix. Adjacency matrix is always a square matrix. Also this is a symmetric matrix. So first row and first column are same, second row, second column, third row, third column coincides, fourth row, fourth columns are same. So adjacency matrix of a graph AG means adjacency matrix of a graph is square matrix, and secondly it is a symmetric matrix. Symmetric matrix. Now we move to second property. These two matrices are same. This is a same matrix as adjacency matrix. Now consider first row of adjacency matrix, which is in front of V1. If I add all the values in row 1, here I get 2 answer. 1 plus 1 is 2. So sum of entries of a row gives information about degree of vertex V1. This is our vertex V1. So clearly vertex V1 has degree 2, there are two vertices which are adjacent to V1. So sum of entries gives information about degree of a vertex. Similarly, for vertex V2, if I add these values, again I get 2 answer. Similarly, vertex V2 has degree 2. So all these vertices have 2 degree, and sum of all the entries in front of these vertices are also 2. This is our second property of adjacency matrix, that adjacency matrix AG gives information about degree of a vertex, degree of all vertices. Now we move to third property of adjacency matrix. As in this adjacency matrix, we see that all the diagonal entries are 0. Here again both matrices are same. Here all diagonal entries are 0. If all diagonal entries are 0 in adjacency matrix, then there is no loop in the graph. So it is clear from the graph there is no loop at any vertex of the graph. If all the vertices, all the entries of diagonal are 0, then there is no loop in the graph. If all the diagonal entries are 0, then there is no loop in the graph. There is no loop in graph. Therefore, we see that adjacency matrix of a graph gives useful information about a graph. All information about graph can be drawn from its adjacency matrix. Finally, we discuss adjacency matrix of complete graph. Complete graph, we know that in a complete graph all the vertices are adjacent, means there is an edge between all the vertices V1, V2, V3, V4. I choose 4 vertices again. Now this is a complete graph, means there is an edge between every 2 vertices of the graph. So this is our complete graph in which all the vertices are connected or all the vertices are adjacent. Again I draw a table for adjacency matrix V1, V2, V3, V4, V1, V2, V3, and finally we have V4. Now for vertex V1 there is no edge, there is no loop at V1, so V1 and V1 takes 0 value. V1 is adjacent to V2, V1 is adjacent to V3, V1 is adjacent to V4, so we choose 1 value for V2, V3 and V4. Similarly for V2, V2 is adjacent to all other vertices, so I choose 1 value here. V2 and V2, as there is no loop at V2, here we choose 0 value, and again 1, 1. Similarly for V3 we have 1, 1. V3 and V3 there is no loop At V3 we choose 0 value and 1 value here. Similarly for V4 we have 1, 1, 1 and 0 value. Now this is adjacency matrix of complete graph. Now in this matrix we see that again all diagonal entries are 0, but all non-diagonal entries are 1. So in a complete graph, the adjacency matrix for a complete graph, all non-diagonal entries are 1 and all diagonal entries are 0, as we see in above graph. As this was not a complete graph, so all non-diagonal entries are not 1 here. So for a complete graph, all diagonal entries are 0 and all non-diagonal entries are 1. So student, I hope you like this video lecture. In next lecture we shall discuss adjacency matrix for digraph, directed graph. So you can get the video of that graph and link is available in the description. So thank you very much for watching this video lecture.